In 2 dimensions, 2 vectors are either parallel or intersecting. Okay, you don't have a third option. Every time you have lines that are intersecting, they are called concurrent. All right, but in 3 dimensions, 2 lines may be neither parallel nor intersecting. Take this example over here using my pens. Okay, they are not parallel, obviously, and they are also not intersecting. They are called skewed. You can only have skewed lines in 3 dimensions. By the way, let me talk about something that I mentioned in the previous lesson when I said that in Math A levels you wouldn't have situations or vectors with 3 dimensions. That is not true for A levels. That was for previous qualifications. In A levels, you may have situations that involve vectors in 3 dimensions. Okay, now that I made this correction, let's continue. So in this type of questions, what can you be asked? You can be asked to begin with to figure out if 2 vectors are parallel. If 2 vectors are parallel, then the direction vector of one must be a multiple of the direction value of the other. So if you are given the direction value of both, look at the coordinates, and if you can transform the coordinates of one into the coordinates of the other by the multiplication of a constant, then they are parallel. If they are not parallel, and if you're talking about 2 dimensions only, then you can be sure that they are going to meet at some point. And you can calculate that point, and that's the purpose of what we're going to do next. If you have 3 dimensions, and if the vectors are not parallel, they can be concurrent, or they can be skewed. The way for you to figure this out is to try to calculate the point of intersection. And if you are not able to find this point of intersection, then it means that they are skewed. So what do you do? To determine the coordinates of an eventual point of intersection of 2 lines defined in vector form, we equal one to the other and solve the simultaneous equations thus formed for each of the line vectors' coordinates. What do I mean with this? Imagine that you have 2 vectors in this form. Okay? So for one of them, I'm going to call this lambda 1. Don't forget that in a question, all of these are going to be numbers, including this. This is already going to be a number. This is a direction vector, and this is a position vector, all right, for each line. So let's say that for one line, this lambda is going to be something, and for the other line, this lambda is going to be something else. So let's say lambda 1 and lambda 2. If you equal one to the other, and I'm talking about 3 dimensions now, you'll have xa, ya, and za, and here the same thing, you have 3 dimensions over there. So after equaling one to the other, you can divide this in lines, 3 lines, one for each dimension. So you will have xa plus lambda 1, whatever that is, equals the x of the other vector times lambda 2 times whatever number you have there. So there you have an equation. Then you will have another one for the y's. Whatever this is, plus lambda 1 times whatever that is for the first line, equals whatever that is times lambda 2 times whatever that is for the second line. And same thing for the direction in the z-axis. So whatever z is times lambda 1 times whatever this value is for the first line equals whatever that is times lambda 2 times whatever that is for the third line. In other words, you have 3 simple simultaneous equations. And what are you going to calculate with these 3 simultaneous equations? Don't forget that all of these are numbers. You are just trying to calculate lambda 1 and lambda 2. So how many equations do you need? You only need 2. So pick any 2 and find the values of lambda 1 and lambda 2. And then what do? You are still having the last equation that you can use to test if the lines are concurrent or skewed. So plug in the values that you just found of lambda 1 and lambda 2 in the third equation, And if you have the same number on both sides, then the lines are concurrent. If you have different numbers on both sides, then the lines are skewed. Okay? And in order for you to find the coordinate of the point P, now that you know the value of lambda, substitute on either one of the equations, and you'll get the coordinates of that point. And that is as simple as that. Okay, I know that the notes that you have here apparently are more complicated than it actually is, but the procedure is just what I explained. What about angles between two lines that are not concurrent in 3 dimensions? We already talked about this for 2 dimensions. You already know what to do. Good news is that you can still calculate the angle between two lines that are skewed. I try to represent this over here. So I have to imagine this over here at one plane and this one at a higher plane. Okay? And this dotted line is kind of a projection of this vector on where the bottom one is. And the angle is this angle over here, okay? Imagine this as the shadow, if it's easier for you, of this vector that is passing on top of that one. The shadow of this one makes an angle with the one that is below. And you can calculate this angle, and the procedure is about the same, okay? It's cosine -1 of the product of these two vectors over the product of the magnitude of these two vectors. And there you have it, the angle, by using exactly the same formula.